Scientists may have discovered water at Mars' equator. If you're looking for another reason to move to Mars, here you go. After re-examining old satellite data from 2002 to 2009 by Mars Odyssey's Neutron Spectrometer, scientists may have discovered ice around Mars' equator. The Neutron Spectrometer can't directly detect water, but by measuring neutrons, it can detect hydrogen signature, which could mark the presence of water or other hydrogen-bearing substances. Researchers discovered an unexpected amount of hydrogen around the equator by reducing the blurred or noise in Odyssey's data using image reconstruction techniques used for other spacecraft and for medicine. This improved the spatial resolution of the images to 180 miles from the previous resolution of 320 miles. Having water on Mars could mean that future human missions wouldn't need to bring water with them for drinking, cooling equipment, or watering plants, thus reducing the number of resources needed for transport. Scientists say more research needs to be done and more evidence collected to determine if the signature is actually from water ice. Looking for a new place to live? Mission complete. A team of scientists have finally returned to civilization after completing a NASA-funded isolation experiment to simulate life on Mars. The 6-person High Seas Mission 5 crew lived in a dome on the Mars-like landscape of Hawaii's Mauna Loa volcano for 8 months. The dome was equipped with a kitchen, bathroom, common area, and 6 individual bedrooms. Though not confined to the inside, the crew were required to don spacesuits whenever they went outside. While in the habitat, the crew conducted scientific research, equipment testing, and resource tracking. They also had to learn to prepare food using dehydrated and shelf-stable ingredients. Communication with the outside were subject to a delay of 20 minutes, the same amount of time it takes for signals to reach Mars from Earth. To better understand the psychological impacts of a long-term space mission, they were fitted with sensors that gauged their moods and monitored interactions with other members. The mission is the 5th in a series of 6 studies designed to help NASA select crews that can do well on an expedition to the Red Planet. The 6th and final High Seas mission will also last for 8 months and is slated to begin in January of 2018. NASA investigates the effects of space radiation on the body. One of NASA's biggest challenges in designing a mission to Mars is how to protect astronauts on the long space journey. NASA's Human Research Program is currently researching how space radiation affects the human body. Space radiation has enough energy to violently collide with nuclei that make up spacecraft shielding and human tissue. The collisions cause both the shielding nuclei and space radiation to break up into several different types of new particles, known as secondary radiation. NASA is currently focusing on the effects of galactic cosmic rays on the human body. GCRs that come from supernovas outside the solar system are the most harmful to the body. One of the main difficulties is that it's hard to simulate space radiation on Earth. Lab doses of radiation could be stronger and given for a shorter time than actual conditions in space.
NASA's laser-powered spacecraft aims to reach Mars in 72 hours. NASA scientist Philip Lubin is working on perfecting laser technology that could propel a light spacecraft to Mars in as little as 3 days. Photons emitted from excited atoms in a laser have energy and momentum, which forms the basis of laser-based propulsion. Photons are released in a beam from a laser. When photons from a laser array reflect off an object, their energy is translated into a push that's capable of moving objects like a spacecraft. Rather than using a giant laser a la the Death Stars, researchers imagine an array made up of a large number of amplifiers that sync up and act like one big laser. The spacecraft launched with this technology will include a robotic probe and a large reflective sail. The spacecraft will be light because no fuel is needed. And this spacecraft could be accelerated to 30% the speed of light, which was previously unheard of. This technology could produce enough momentum to get a robotic spacecraft to Mars in 3 days and send a manned shuttle to Mars in a month. Using photonic propulsion, interstellar travel may be possible, and we could get a probe to Earth's nearest star, Alpha Centauri, in as little as 15 years. In comparison, our current technology takes 4 to 8 months to get to Mars. It took 37 years for the Voyager 1 spacecraft to reach the edge of our solar system.
Life on Mars?
Mars may not have been an arid wasteland after all, at least according to a new study that suggests the red planet may have been far more habitable than previously thought. Martian meteorites contain a specific mineral that has long led scientists to believe the planet had an ancient, dry environment. The mineral, called marlite, contains no water or hydrogen, which led to the assumption that its origins were likewise devoid of liquid. But new research now suggests that marlite was originally a hydrogen-containing mineral, and that Mars may have had a more water-rich history. When an asteroid or comet collides with the planet, the force of the collision propels Martian rocks containing Whitlockite out into space. Researchers theorized when these rocks enter Earth's atmosphere as meteors, the shock, pressure, and high temperature sustained during impact dehydrate the mineral, turning it into marlite. They tested the theory by blasting synthetic Whitlockite with a gas-powered gun at speeds of more than 1,600 miles per hour and with huge amounts of pressure. The shock experiments were sustained for only a fraction of a second, but already resulted in partial conversion, with 36% of the mineral transformed to marlite. The findings suggest Mars could have had a more abundant water supply. It also hints at the possibility of life on the red planet, as Whitlockite is water-soluble and contains phosphorus, which is an essential element for life. More detailed studies of Martian meteorites may provide more insight, but a Martian rock taken and transported to Earth will likely be needed for confirmation. For now, scientists need to make do with thermal imaging and rock sample analysis from the rovers.